All right, welcome to Chapter 5, Section 2, called Geometric Proof. This is for Math 8. So just as always, go over a couple of the features on the screen here. So the first thing you should see is a due date. I don't see it on the teacher preview, but you'll see it on your student side. The other thing is the attempts here. It's always unlimited attempts, so make sure you can come back in and try this assignment as many times as you would like. That's true for homework assignments, quizzes, and tests. This particular section only has 2 questions on it, so it just depends on the section there for the number of questions. Grading policy is always best score, so whichever attempt is the best one is one you keep. And partial credit is always enabled. So if you answer one of 2 questions correctly, you get credit for the one question. Or if you answer both, you get credit for both. This statement down here is just once you start your homework, you must finish it before you can work on anything else. And I might have cut off the start button down here, but I'll go ahead and click on it. So I just went off the screen to click on the start button. So once you're down here in the bottom right-hand corner of the screen, you will see a Submit Assignment button. You always want to make sure you click that button when you're ready to leave this screen, whether or not you've started anything, or if you've only answered one of 2 questions, make sure you do have a green check mark to get the credit for answering it, because if you just click on a couple of things, but you don't actually check it and click, get the green check mark, it doesn't count. But once you're ready to leave, you click that Submit Assignment button. It does 2 things. It stops the system from locking you out of all of your other assignments, and it makes that assignment show up in the grade book. So now your teacher can see what you've been doing, and hopefully it will make a positive effect in the grade book for you there. Otherwise, the system will lock you out of everything, so just keep that in mind. On the side here, we have explanation, example, and message center. So explanation tells you you're going to lose your current question attempt because it's going to literally give you the solution to this question. So you don't get the solution and then get to come type it in. You're going to have to come in on another attempt and try again. Example does give you a very similar example and show you exactly what it wants you to do for this type of example or this type of problem. So you can look through there, read through all the examples. If you want to see another one, you can click on example again. It'll give you another example. You can also message your teacher directly from the screen so we can see where you got stuck or where you need help. Okay, so let's go ahead and take a look at this. It says 2 parallel lines, M and N, so we can see M and N, are cut by transversal B as shown. So transversal, remember we did this on the last section. Transversal just means a line that's crossing another line. So in this case, I can see B is crossing over these other 2 lines, which are parallel. And if we have parallel lines, we also have some of these other relationships. We have alternate exterior angles, alternate interior angles, corresponding angles, and these are all congruent to each other. If those don't sound familiar at all to you, go back and watch the video for section 1 because you need to know what those mean in order to do this proof. And I already went over those in pretty good detail in section 1. So go back, watch that video, and then come back to this one. All right, so what it wants us to do is complete the statements below. So since we see that angle 2 and angle 3 are something, and if we could do this drop down, we can see it's going to be corresponding vertical angles, alternate interior angles, or alternate exterior angles. So vertical angles have nothing to do with parallel lines. It's just whenever 2 lines cross. So whenever we see like this X happening, we have a vertical angle. So 2 and 1 are vertical, but 2 and 3 would not be vertical because they're not in the kind of X together, okay? But if I look at 2, I could slide it right over to 3. So they're both on the left side of their parallel lines, and they're both above the transversal. So that makes them corresponding angles. Again, if that was confusing, you're not sure what I'm talking about, go back and watch the section 1 video. I went over the definitions for these quite a few times in the last half of that video. Since the lines M and N are parallel, angle 2 and angle 3 are congruent because corresponding angles are congruent. So angle 3 is equal to, well, they told us angle 2 is equal to 115. So if they're congruent means the same size and shape, which if they're the same size and shape means they're also the same angle measure, which is 115. We see that angle 1 and angle 2, well, we just talked about that. They're across the vertex from your opposite. So that's called vertical angles. That has nothing at all to do with parallel lines, but we tend to use it a lot when we're doing angles, especially if we have lines crossing. Thus, angle 1 and 2 are, again, congruent. So these have kind of the same relationship here. So angle 1 is equal to, well, if angle 2 is equal to 115, again, angle 1 is also equal to 115. Therefore, angle 1 and 3 are congruent, right? They're both 115 degrees. They both equal angle 2. So, because 3 is corresponding to angle 2 and 1 is vertical in angle 2. They're both the same size and shape as angle 2, which means that they're both congruent or equal to each other. So with these ones, we want to make sure that we categorize them correctly. So when we're talking about interior, this is the interior inside the parallel lines. Exterior would be outside here or outside over here. So if I'm looking at 3, I have exterior angle here. I'm going to go to the other side of the transversal and slide as far as I can go, and I land on 1. So these are called alternate exterior angles. They're on the outside of the parallel lines, and they're on opposite sides of that transversal, that line that's crossing the two. So the relationship between angle 1 and 3 is an example of the following rule. When parallel lines are cut by a transversal, alternate exterior angles are congruent or supplementary. So be careful, they're giving you both. They're always going to be congruent, not supplementary. That's not how those work. So make sure you're picking the correct statement there. All right, again, I don't think you can see the check, but I'm clicking check down here below. I accidentally cut it off in my screen recording. All right, we're going to do one more of these guys. Okay, so two parallel lines, U and V. So we have U and V are cut by this transversal B here. We also are told that angle 1 equals 75. So we see the angle 1 and 2 are, and again, these are across the vertex from each other, so right away I know those are vertical angles. Angle 1 and 2 are congruent because vertical angles are always congruent. So if angle 1 is 75, angle 2 is also 75. We see that angle 2 and 3 are, well, I can see that angle 2, if I'm thinking of the parallel lines, they're both on the right side of the parallel line, and they're both below the transversal. So I can describe them in the same way. They're to the right and below for their respective position. So that means that they are corresponding to each other. I can also looks like, it kind of looks like I can take 2 and almost just slide it right over onto 3. So it's kind of another way you can identify the corresponding angles. They look like they could just slide right on top of the other. So corresponding angles are congruent to each other. So angle 3 must also be 75 degrees. If angle 2 is 75 and I can bring this one down here, then this must be 75 degrees as well. So therefore, angle 1 and 3 are congruent because they both equal, well, 1 is 75, and we just proved that 3 is also 75. So 1 and 3, we have exterior. I'm going to go to the opposite side and slide down. So these are alternate exterior angles. So we're proving that alternate exterior angles are congruent when you have two parallel lines cut by a transversal. So make sure, again, they're giving you multiple pieces to choose. Make sure you choose alternate exterior angles and that they are congruent. All right. So that was section 2. I will see you in section 3.